Alright, I think I should be live right now. Let's see. Let's see, guys. Sorry I did not double check on this earlier today, but I'm trying to fix my front webcam right now. Let me see what's going on right here, bro. I'm gonna restart it. Alright, oh snap. Okay, I do not look that great right now. Okay, let me just send a quick little text before I actually get focused on what I'm about to do with you guys, okay? Give me a second. Give me a second, guys. Sorry. I know this live stream is not going the way it's supposed to, but I promise you that we're gonna get work done in a little bit, okay? Okay. All right then. Alright, so in my last live stream, so first of all, I'm gonna be straight up with you guys here. I've been like feeling some sort of procrastination lately, to be honest with you, and it's the secret is catching yourself when you're feeling this way, because when you don't catch yourself and you're not honest with yourself of like, yeah, it's natural to feel the procrastination, then it's a bad path you're going to lead to, and you're most likely going to fall off the track and not do what you're supposed to do. Okay, now that I opened up about how I've been feeling as of now, I'm hoping that through this live stream I'll be able to feel a little bit more better with you guys, and you know, get ready to get back into that zone that I just have not had time to do these past few days. But that being said, I want to review with you guys my solution that I got for the Mario versions right over here. So, quick little recap. If you haven't seen my previous live stream, the goal was to make a pyramid for what's it called, for this problem. So pretty much, it first started by building the opposite, where it's indented to the left, right, where you have no, you don't have to do any extra special coding features or whatnot. And then right after, you need to figure out how to push the hashes to the right, right indented. So that was the Mario less, and the other Mario was the hard one, which is making two pyramids, one left indented and one regular right indented. And we're gonna go through this real quick with you guys before I start from scratch. Cash less. I'm gonna do cash less first because honestly my goal is to stay on track with my schedule, and I need to start week 2 tomorrow. So, and I also do not want to be up super late, because I've noticed that when it comes to approaching goals that you set out for yourself, you need to make sure that these goals are realistic and you have a balance with everything in your life. And unfortunately, with me, I have not been balancing my health, which is fitness, by how addicted I've been with this coding. And it's good, right? Like I said, it's good to be addicted to coding, but I know that if I don't take care of my health, it's gonna get me right back into the future, and that's exactly what I don't want. So let's go right here. As you can see, this is the cache. We're not going to focus on this right now. We're actually going to focus on the Mario.c, and you can see that I've came up with various different solutions, and I'm actually going to show you guys my version 3 solution here. Okay, actually no, this is another one that I did not do from scratch. This is actually someone else's solution that I found online, and I was just reviewing it. But I'm going to be quite honest with you guys that I'm going to show you my personal work that I've worked on. So right over here, This is Mario Less, right? Mario Less was, if you guys recall, it was only one pyramid indented to the right, not these double pyramids here. So with Mario Less, as you could see, I start off the program by having these two libraries included into my file, and this is the entry point that I have for the program, which is int main void, the function. We know by the rules that we want to set a certain height to get from the user who's going to input their number through the terminal, right? So, for example, let me just run this program for you guys real quick. Right, so we know that we can't put anything less than 1. We can't put anything greater than 8, right? You see, nothing like that. But if we have a number, let's say like number 5, boom, we have a right indented pyramid here. So this is practically the solution of this is the outcome that we really did want to have come out. So the way how I prevent users from giving me a number less than 1 or greater than 8 is this code right here. I figured that we were going to work on a do while loop. As you can see right here, I declared the variable right here, and I'm hoping I'm using the right terms, by the way. So I declared the variable right here, and how do you say it? Declared, initialized. I'm not going to focus on the terminology too much with you guys. Anyways, I pretty much set the variable here. I grab the height, the correct height from the user, and now that I have this height, right, now that I have the height that I really wanted from the user, this is where the magic happens. So this number is very important because it is what determines literally the rest of the logic that I need to figure out. The amount of columns, the amount of spaces, the amount of hashes, etc., 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 the amount of rows, right? So for example, right here we have that it's 5 rows. Right over here I am setting up a for loop, right? A for loop here where I've declared a variable called row, and I have set it to the number 0. So pretty much right here what it's saying is that is 0 less than, like using the example, right? This example right here that I gave you is 0 less than 5. Let me give a comment out for you guys. So is 0, so this is the first time it's running, right? Is 0 for row 0. Is 0 less than 5? That is true. So now that we have 0 less than 5, we also know that spaces equals height minus row minus 1. Now, why is spaces height minus row minus 1 for row 0? Remember, our goal is to get this right over here, right? Let me see if I could copy and paste this code down here. Okay, cool. Damn, okay. So if you guys notice here, I'm gonna actually add for you guys 2, 3, 4 these characters here. I haven't even reviewed this code in quite a bit, but it's gonna work, you guys. So look, for row 0, follow the arrow. This is what we want row 0 to look like. This is what we want row 1 to look like. Row 1, row 2, row 3, row 4. So as you can see right here, spaces is important because I need to get some sort of dynamic way to get the amount of spaces per row. And I figured that this was a common pattern that I ended up seeing when I would use my graph. So another thing too with my solutions is that I grab a piece of paper and write down like anything that gets me closer to the problem. So I ended up finding a pattern, right? I ended up finding a pattern, and this pattern was what you're seeing right here. For every row, this was the pattern that got me the correct amount of spaces, no matter what the number is that I'm going that I needed, right? Because if you notice right here, the last row is going to have to equal 0, and you'll see right now how that works out. So if you see right here for the first row, it's height 5 minus the row number, which we're currently at the 0, minus 1. You might be asking yourself, where the hell does this minus 1 come from? Like, why are you writing minus 1? Well, that's just us. That's just the algorithm. That's just what I had to add in order to make sure that the algorithm was going to work. That was the way that I was going to get the correct amount of spaces, by including that minus 1. So by including that subtraction into my two variables, which is height and minus row, I was able to get the correct answer of spaces for row 0. So now that I have this number, right, now that I know that spaces equals 4 for row 0, now I could use this number to create a for loop that would print out the right amount of spaces needed per columns. So if you see right over here, what we have here is columns less than spaces equals 4. So if you see columns plus plus, so let's imagine that this is a space, this is true. And if we increase row, this is still true. We increase row again, this is still true. And if we increase row again, this is another one. And if we increase row one more time, is 4 less than 4? No. So what does that mean? We have on row 0 printed out four spaces, and now we move on to the next thing. Remember, we're still in row 0, but we're focusing now with inner loops to print out the columns one by one by one. Now the question is, Alex, how do you get the correct amount of hashes to pop up? That's where we're heading to now. So same thing, right? Same thing. We start off with columns equals 0. We know that we figured out the amount of correct spaces that we were going to need. We know that column equals 0, and if columns is less than or equal to 0, which in this case row equals 0, add 1 to column. But before we add 1 to the columns, we need to print out a hash. But remember, we're not printing out individual hash right over here. We're not printing it out. We're actually adding this hash to these 4 spaces that have already been printed from the previous loop, because remember, we're still at row 0. So in actuality, for row 0, what we've done is printed 4 spaces in 1 hash, which is exactly what we needed for this row 0 right over here. And by doing it like this, I was able to now focus on by doing it the answer this way, as you can see right over here. Let's say we added another column, right? Is 1 less than or equal to 0? No, it's false. Boom. We have exited out of this for loop, and now we've printed a new line, and now we have gone all the way back up to this one. We have now finally added to row. Now, the next thing that we're going to see here is row 1. So what do we have? We have spaces minus 1, since it's row 1, minus 1. Spaces equals 3. So now that spaces equal 3, as you can see over here, this is 0 less than 3, true. We add another one, 1 less than 3, true. 2 less than 3, true. 3 less than 3, no. So that makes 3 spaces, right? 3 spaces right over here. We're still on this row. We go down over here. We're on row number 1. So we start at column 0. 0 less than or equal to 1, true. We add here. We print out the hash. We add right here. 1 is less than or equal to 1, true. We printed out our second hash. Our second hash. And that's what we have for row 1. So as you can see right here, I hope you guys are understanding what I'm trying to get to here. But I've made sure that for every single one of these rows, the correct amount of spaces and hashes is being printed out. And this was a very good exercise. I wasn't able to get this right away, but with a lot of thought process, I was able to actually get the answer to it. And that's the key, guys. That's the key about this, that you need to make sure that you practice. I'm telling you, me right now, to be honest with you guys, I had to review this code on the live stream in order to actually revisit it and let it sink in again, because remember, I haven't been on my computer for the past 2 days, and just by not being on this computer for the past 2 days, I've noticed like, whoa, I need a refresher. But this is good. This is good because it's making me appreciate the importance of consistency. Okay, now let's revisit a version 3 of Mario Less. So this guy ended up making his solution a little bit different, and as you can see, he only has one loop, for loop inside his for loop that is in charge of the rows. The rows are the same thing. Row is less than height, so you get the correct amount of height rows by relying on this condition here. And right over here in your inner for loop, where you are pretty much, the guy ended up finding out a very interesting solution. So the pattern he found was, if row plus column, which in this case is row 0 plus column 0, if 0 is less than height minus 1, you're going to print out a space. So I guess what he's trying to say is, okay, for the first element, I guess you could say for row 0, 0 plus 0 minus 5 minus 1 is 4, so 0 is less than 4, true, you print this out. Now what does that mean? You go back up here, 1 is 1 less than 4, okay, go right here, 0 plus 1 is 1 less than 4, yes, go up right here, add again, is 2 less than 4, let's go here, 0 plus 2 is 2 less than 4, yes, go up again, is 3 less than 4, is 3 less than 4, true. And if you go up right over, up right over here, I'm sorry, I've been saying the wrong height variable here, is 4 less than 5, true. Is 0 plus 4, 4 less than 4, false. So you print out the hash. Interesting pattern. I wasn't able to do this by myself, but I could see where the guy got the idea from. And I honestly, it looks confusing at first, but just give it some time. You'll be able to let it sink in, and it would make a lot of sense. All right, so that was the Mario Less. Now let's go with my solution of doing Mario More. Practically, it's the same thing, you know, from the previous Mario Less, the same information right over here, but um, you're adding after you've printed the right indented pyramid, which is the like the left pyramid, you're going to add 2 spaces per every row and focus on a regular pyramid. That's it. That's really it. Nothing out of the blue here. That was just the solution. I'm gonna share it with you guys right over here. So if I go here more, and I run the program, and I say, let's say I want 8. Boom. Check it out. Remember, it's the exact same thing. I'm printing out the exact amount of spaces I need, which for row 0 would be 7. I print out the hash, right? Is 0 less than or equal to 0? It's true because it's row 0. Print out the hash. Is 1 less than or equal to row 0? It's not, so you know, you focus on the next thing. I print out 2 spaces, 1, 2, and I focus right here. Is 0 less than or equal to row? If it is true, then you just print out the hash. I just wish, now that I look at this, I just wish it wasn't repetitive, right? Because it's just literally the same exact code right over here, but I didn't have time to look for a better solution to the problem. But this was it. This was it, guys. Cool. It took about 20 minutes or so to go through this. Sorry for you guys who thought that I was gonna go right away to the cash program, but now I am. Okay, let me just take a little water break here. Damn, I barely have water in my hydro flask. Damn. Let's see. My brother's texting me right now. He's telling me that he's doing a Node.js bootcamp online, and he's insisting that we do it together. Hey, that's cool. Let me see. Hold up. I'm sorry, guys. I feel like I'm distracted right now, but let's see. Okay. Okay, y'all. I'm taking a picture right here for y'all. Cool. Okay, dude, damn, I'm acting like I don't have to. I just gotta get in the zone. Okay, let's review this because I have not reviewed this either. Let's review.
If they were to suddenly...
Okay. But I did that to make sure that my microphone was working. I mean, my headphones were working because I'm having issues with that right now. Okay, you guys. So I already did this. I did the weekend. I already unzipped this. This is less, I believe. I'm gonna double check. Actually, just we're gonna start with my goal is to at least finish up the less comfortable before midnight. And if I have time for the credit, I'll do the credit. But if not, well, dude, I just really need to make sure that I advance and stay on track with my schedule here that I have. Okay, so we go down here, CD into cash. Maybe it'd be better if I were to just do this here. Oh my god, freaking my. Okay. Okay. Alright, you guys. CD into cash, I'm in cash. Okay, so this was already pre-made code for us that was already added. Greedy algorithms. Let's see. Yeah. I think from what I've read prior to the live stream, this is pretty much, you know how you go to, like, let's say a grocery store or something and you pay with cash and these coins automatically dispense out of this little machine, and like as the cashier is giving you cash back at hand, there's a machine that has already dropped the correct amount of change into this little pocket, you could say, pocket that the machine has on the side where the coins are dispensed at. So practically that's what we're trying to figure out with C. How do we print out the, at least in this case, get an output of the correct amount of coins needed? For sure, off the jump, I already know that we're gonna need to have a C. We're gonna need to have to use switch statements for this C language. So let's check this out. Off the jump, I just know. I just already know. Let's see. Let me write this stuff right over here for you guys. Cash.c. Greedy algorithms. Okay. I'll read it one time for you guys. When making change, odds are you want to minimize the number of coins you're dispensing for each customer, lest you run out or annoy the customer. Fortunately, computer science has given cashiers everywhere ways to minimize numbers of coins due to greedy algorithms. According to the National Institute of Standards and Technology, a greedy algorithm is one that always takes the best immediate or local solution while finding an answer. Greedy algorithms find the overall or globally optimal solution for some optimization problems, but may find less than optimal solutions for some instances of other problems. Alright. What does all that mean? Well, suppose that a cashier owes a customer some change, and in that cashier's drawer are quarters, dimes, nickels, and pennies. Of course, 25 cents, 10 cents, 5 cents, 1 cent. The problem to be solved is to decide which coins and how many of each to hand to the customer. Think of a greedy cashier as one who wants to take the biggest bite out of the problem as possible with each coin they take out of the drawer. For instance, if a customer is owed 41 cents, I'm going to write this down. Example, 41 cents. The biggest first, or the immediate or local bite that can be taken is 25 cents. So, 41 cents. You could fit in 25 cents. So what would that leave us with? That would leave us with 16 cents. So we've already used a quarter. From these 16 cents, we could add a dime. We subtract that, we have 6 cents. So now we have a dime. A nickel, from that 6 cents, we subtract the nickel. Then we have a penny. A total of total coins, we would have 1, 2, 3, 4 coins total dispensed back to the customer. Four coins in total. Yep, 4 coins in total. I just wonder how it would be for a number like, let's say 78. How do you make, I think I'm getting ahead of myself right now, but how do you make a loop to make sure that it's checking over and over and over again? Okay. It turns out that this greedy approach is not the only optimal is not only locally optimal but also globally. So for America's currency and also for the European Union's, that is, so long as the cashier has enough of each coin, this largest to smallest approach will yield the fewest coins possible. How few will you tell us? In Cash.c, we've implemented most but not all of a program that prompts the user for the number of cents that a customer is owed and then prints the smallest number of coins with which a change could be made. Indeed, main is already implemented for you, but notice how main calls several functions that aren't yet implemented. Are these the functions? Oh, okay. But notice how main calls several functions that aren't yet implemented. One of those functions, get sense, takes no arguments that are indicated by void and returns an integer. Okay. What the hell? And the rest of the functions, I'll take one argument and also return an integer. All of them currently return 0 so that the code will compile, but you want to replace every to do and return 0. With your own code, specifically complete the implementation of those functions as follows. Implement get sense in such a way that the function prompts the user for a number of cents using get int. Okay, let's see. Function prompts the user for a number of cents. So this prompts user for a number of cents. Inputs a negative number, your code should prompt the user again. No negative numbers. Your code should prompt the user again, but you don't need to worry about the user inputting a string, as getIn will take care of that for you. You'll do while loop at help. Okay, so use do while loop. Okay, off the bat, since it's already telling us that we're gonna use getInt, don't worry about floats. Because I was thinking, right, like, what if I wanted to do, like, well, it wouldn't make any sense. Like $1.79, right? $1.79. You just subtract the dollar. I mean, that's just already complicating what they're already asking us here. So I'm gonna do that. So I guess this will be problem number 1 to focus. How to prompt user. Okay, check. Implement calculate quarters. Okay, what does it want from here? Calculate quarters in such a way that the function calculates and returns as an integer, right? How many quarters a customer should be given if they're owed some number of cents. For instance, if cents is 25, then calculate quarters should return 1. If cents is 26 or 49 or anything in between, then calculate quarters should also return 1. Okay, so how many quarters are owed in this? I guess that's all I'll put. So it's asking for the same exact thing, but besides quarters, dimes, and besides dimes, nickels, and besides nickels, pennies. It's the same thing it's asking for. I feel like I'm gonna have to do another do while loop. Do while, not even a while loop, while, let's say, sense is less than 25, greater than 25. So I'm doing pseudocode right now. Actually, yeah, let's do some pseudocode here. Oh man, I'm gonna be real with you guys. It's not easy to get back in the zone. What the hell? It's not easy to get back in the zone, especially when you've been like feeling kind of sluggish. But you know, there are days where you're gonna feel where I need to find the joy again. But hey, it happens. It happens. I'm glad that I'm able to catch these feelings again. Okay, so while this is happening, I feel like sense will need to be modified. Like the variable sense that I'm getting will need to be modified. Oh, it's already doing that for me. Hold up, guys. What the hell? So what's clicking on my head right now? I guess the question is going to be how many quarters could fit in sense. Okay, I think I'm understanding the problem a little bit now. Okay. So since I know sense already exists up here, dude, what the hell? I guess I have to initialize here. Int, get int, enter, what does it want me to say? Sense owed. Let's see. Let's just give you an example of how much I could put here. Alright. Enter sense owed. That. And we have to do a do while loop. Do. Okay. Okay, I think I understand it now. Okay, guys, it's gonna be very hard for me to like explain my mental process, but I'm gonna do my best. Okay, so right now what I'm trying to do is create the do while loop in order to make sure that I'm actually getting the correct amount of. If you input 0, does your program output 0? Okay, so it's telling me no negative numbers here, right? If user inputs a negative integer, your code should prompt the user again. But you don't even, okay, so So 0 is an acceptable answer because what is that going to do? It's going to make sure that we are able to just return 0. No negative numbers. Okay. Guess this is what I'm going to test out first. I'm going to make the file cache. Okay. Cache. Make sure that we can't do that. -2, 0. Returns. What the hell? How did it get that number? Did it get it from here? Is it outputting this number? Let's see, guys. Let's see. Okay, so that's not it. What is it doing with this freaking number? So if I put 21, it returns 21 quarters. No, I haven't even done anything here. Get cents. Cents equals get cents. 21 minus 0. The hell? How is this? How the hell is this working here? 21. Pause, you guys. I need to. My head's going out in circles right now. Dude, okay. Get cents. Okay, so if I'm not tripping, this should be 21. 21. 21 minus 0 is 0. Times minus 0, 0, 0, 0, 0, 0. 0 plus 0 plus 0 plus 0 equals 0. Since it's coins, but let's say if we want to get. Alright, I understand that part now. Okay, I get it now. I get it. So these variables here, they're coming from the results of what I'm bringing back from these functions. And this is pretty much making sure for me that I'm subtracting the correct amount of quarters, dimes, nickels, and pennies from the cents until it is to 0. Okay, I got that part now. So I think they're all gonna kind of look the same. If I'm not mistaken, let's just try this out right over here. While since while quarters equals 0, while since is greater than quarters, what do I want to do? While since is greater, so let's say an example would be 50 is greater than 25. What do I want to do? Quarters plus plus cents minus 25. I think that should work, if I'm not mistaken. I should get 2. This should add to 2. Minus 25, minus 25, and then I'm going to return quarters. Let's see. If this is the answer, that means I have an idea of how this is going to work. Okay. Seems like I have the idea of what's going on here. Okay, so let's try the next example, right? 60 cents. Let's follow the same concept here. While cents is greater than dimes. Wait a second. What am I doing? Hold up, guys. Am I tripping? While cents is greater than 25. What the hell? I'm tripping. Okay. While cents, let me code this a little bit better. While cents is greater than 10, what we want to do, is dimes plus plus, and we want cents equals cents minus 10. And then it's going to check if cents is greater than, okay. Then we want to return dimes. Okay, so let's test this out again. Let's go with 60. If I put in 60, I should get 3 coins back. 2 quarters, 1 dime. Hmm. 60. Why is this not freaking working? I know this is correct, so why can I not, like, lower this? Oh my god. I'm gonna have to split this. Okay. Get cents. I'm making sure I'm getting the correct amount of cents back. Calculate quarters. Am I tripping? How am I messing up right now? Two. The hell? 4. What the hell is going on? How am I getting 4? What the hell? what would happen if I put 0? Okay, at least I know that's alright. Alright. Since enter cents owed. Wait, enter cents owed 0 coins 0. Calculate quarters, integer cents. While cents is greater than or equal to 25. Because that is true. If it's 10, then we want to subtract 10 out of it. Let's see. Let's go. Let's test one more time. Let's test 60. Let's go, bro. Let's go. Okay, let's test 85. 85, it should be 3/4. 85 minus 75 is 10. It's 3/4, 1 dime. Whew. Esto ya se hizo. Let's see. Alright, dude, so int nickels equals 0, and we want to return nickels. So while cents is greater than or equal to 5, we want to first we want nickels to plus, and we also want cents to equal cents minus 5. Cool. Let's test that out. Let's give an example. Let's say 90. 90 should give us 5 coins. 90, 5 coins. And if we do 96, it should give us 6 coins. That's how we're going to test this one out here. So in pennies equals 0. Wow. Cents is greater than or equal to 1. We want to cents equals cents minus 1. Return pennies. If we do 96, it should be 6. Okay, cool. That was not that bad, to be honest, but let's now test these edge cases right over here. Hold up, guys. Okay, let's see. Okay, let's test it out. Let's see if I put -1, it shouldn't give me nothing. If I put 0, it should give me back 0. If you input 1, does your okay, gives me back 1. I know I added this, by the way. If I put 4, it should give me back 4. If I put 6, what number is it telling me? Oh, 24. It gives me back 6, 2 dimes, 4 pennies. Yep. Looks like everything is good, guys. If I put 99, it should give me 3/4, 2 dimes, and 4 pennies, which would be 9. Yep. Alright, let's check this out. Let's see. I'm hoping that it's good. Let's check out my GitHub account now that we're here. GitHub.com/this name. Cool. You see, these past 2 days I haven't been on. As you can see, kind of catfishing right now because that's exactly how I do not look on this live stream, but it's all good. Alright, the point is that, oh, we're waiting for the results still. Let's see, as we're waiting for the results, ooh, Okay, okay. Nice. Let's see. Let's add this up right here. Let's submit it. Let's hope and pray that it actually goes through. Yes. I'm gonna take a picture of this right here. Oh man, this is pretty freaking cool, dude. Okay, so my results should appear here. Let's see. Damn, 73 commits, god damn. Let's see, let's see, let's see. I just submitted this a minute ago. Nice, look at that. Cool, cool, cool. Let's see what's up right here. What the hell? I know nothing about this right here. Cool. Cool, cool, cool. Well, why don't we give a try to the other one right over here. What is it? What was it called? Cashless? What was it? Oh man, honestly, I'm actually happy that I'm recording my progress with you guys, and that that I was able to catch myself like feeling like I was not on the path. Like, how do I explain this? This it's like maybe people that go to the gym would like know what I'm talking about. Like when you don't go to the gym for a couple of days and you try to get back into the zone of going to the gym and stuff like that, like the first couple of days is a pain in the ass, but once you get back into the zone, it's all good. And right now I just felt like, because of life and the stuff that I had to go through, nothing bad happened, but like I had errands to attend. um, it made me, kind of like sway to the other, like sway away from my goal. But now, as I'm recording myself, I'm able to, let me go right here. I'm able to just figure out how to get back into the zone, which is the most important key that everyone should learn to do, especially when they're following their goals and their dreams. Because no one else is going to do it for you, and no one else is going to teach you how to do that for you. And you have to be the one to do it for yourself. And I'm happy that I was able to do that for myself today. Dude, super cool. Let's see over here. What's up right over here? Alright, let's see what is up. Alright. That's it. Credit. Alright. Remove the credit. Zip file. Buy credit.zip. Now we go into the credit. Damn, okay. Let's see what we got. A blank file. Okay. Give me a second, guys. Give me a second, guys. I'm trying to get my brother to do this program, the CS50 as well, because yes, we've coded in the past before, but at least in my experience, not understanding like computer science and stuff like that, it just makes coding hard. Like, yeah, you understand like what these functions and stuff do from the docs you read, but at least these basic fundamentals, dude, I think it would not hurt at all to just, you know, have that imprinted in the brain. Let's see. Okay. All right, y'all. Something tells me that this credit one might be a little bit more challenging. But give me a second, guys. I'm just happy that I could honestly say that I'm gonna be on the right track for week 2, which is a raise. Nice. could be such an addiction. Ah. Alright guys, let's focus before life distracts me more. Okay. Cool. So I was able to do the Cash.c one, which was not bad at all. This credit one might be different. Let's read through this. A credit or debit card, of course, is a plastic card with which you can pay for goods and services. Okay, before I even read any of this crap, any of this, let me include the libraries I already know I'm going to need. Void. And so if this can work, return 0. Cool. All right. Okay. A credit or debit card, of course, is a plastic card with which you can pay for goods and services. Printed on that card is a number that's also stored in a database somewhere. Ah, damn, I think I know where this is heading to. Let's see. In a database somewhere so that when your card is used to buy something, the creditor knows whom to bill. There are a lot of people with credit cards in this world, so those numbers are pretty long. American Express uses 15-digit numbers. Okay. 15 digits. MasterCard 16. I'm writing this down on my my graph paper because something tells me it's just going to be something important to take note of. Visa uses 13 and 16 digits. Okay. And those are decimal numbers 0 through 9, and not binary, which means, for instance, that American Express could print as many as quadrillion numbers. Okay, well, for sure we're not going to reach that population, let alone the global financial users are not going to be able to fill up all those numbers. Okay. Actually, that's actually have some structure to them. All American Express. Okay, so we know that Amex, not only do they have their amount of digits, but they also have, they start with 34 or 37. Starts with 34 to 37. MasterCards. Starts with 51, 52, 53, 54, and 55. And all Visa numbers start with 4. Visa starts with 4. Okay. But credit card numbers also have a checksum built into them, a mathematical relationship between at least one number and others. That checksum enables computer. Dude, I need to read this clearly. But credit card numbers also have a checksum built into them, a mathematical relationship between at least one number and others. That checksum enables computers or humans who like math to detect typos, transpositions, if not fraudulent numbers, without having to query a database, which can be slow. Of course, a dishonest mathematician could certainly craft a fake number that nonetheless respects mathematical constraints, so a database lookup is still necessary for more rigorous checks. Huh. Interesting. The dark mathematicians at it again. Let's see. Each cards. Okay. Bloom's algorithm. Most of the cards use an algorithm invented by Hans Peter Lim of IBM. Let's give you credit where it's due, Hans. Are you damn? Rest in peace, my man. Rest in peace for reals, because Jesus. Bloom's algorithm. Starting with the number second to last digits. Okay, what? Okay, dude, I need to read. Multiply every other digit by 2, starting with the number's second to last digit, and then add those product digits together. Second to last digit, and then add those products digits together. Products digits together. Add the sum to the sum of the digits that weren't multiplied by 2. Alright, it already sounds kind of tricky. So it says multiply every other digit by 2, starting with the second to last digit, add product digits together. Add the sum to the sum of the digits that weren't multiplied by 2. If the total's last digit is 0, or put more formally, if the total's modulo 10 is congruent to 0, the number is valid. If the total modulo 10 is 0, the number is valid. It's kind of confusing, so let's try an example with David's Visa. Okay, let's see, man. Ooh, I know this one is not gonna make me sleep early already. But that's the game. Let's see. Okay, an example. Let's see. This is a visa. Zero, 036. Damn, how many freaking zeros are there? 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4. So we have 1, 2, 3, 4, 5, 6, 7, 8. So, starting with the second to last digits, add products digits together. So we multiply each of these digits by 2, okay, so this would be 1 times 2 this would be step 1, 1 times 2 plus 0 times 2 plus 0 times 2 plus 0 times 2 plus 0 times 2 plus 6 times 2 plus 0 times 2 plus 4 times 2. That gives us 2 plus 0 plus 0, 0 plus 0 plus 12 plus 0 plus 8, which would give us 22. What? How many? 13? What the? Am I true? How does that give us 30? Wait, how the hell? Now let's add those products digits, not the products themselves, together. Interesting. Add the digits. So this would be 2 plus 0 plus 0 plus 0 plus 4 zeros plus not 12 plus 1 plus 2 plus 0 plus 8. So 2 plus 3, 5 plus 8 equals 13. Whoa, this is kind of intense. Step 2. Add the sum to the sum of the digits that were not multiplied. That weren't multiplied by 2, starting from the end. Okay, so this number, 13 plus 4 plus 0 plus 0 plus 0 plus 0 plus 0 plus 3 plus 0 7. This would be 20. 3, step 3, 20 modulo 10 equals 0, and it is valid. So validating credit card numbers isn't that hard, but it does get a bit tedious by hand. Let's write a program. Oh, dude, I need to pause for a second. This is gonna be kind of intense. Okay. Let's see.
Pitch black, even with light, doesn't go far. Everyone posting it.
House, the camera's right in my face. This is with the red light on. But now watch this. Alright, we're inland right now, so we got sunlight pollution, but this is with the spotlight. Still can't really see shit. So, yeah, it's dark as fuck out here. For the people asking how do we know
Alright, dude. Oh my goodness. Let's see. Let's see this shit, dude. In the file called credit.c in the credit directory, write a program that prompts the user for a credit card number and then reports whether it's a valid American Express, MasterCard, or Visa number per the definition of each formats herein. With some tests of your code, we ask that your program's last line of output be Amex or MasterCard or Visa or invalid. Okay, fuck. What the fuck? Okay, how do I do that? In the file called credit.c in the credit directory, write a program that prompts the user for a credit card number guess. I'm gonna do get long. Oh my goodness. Alright, this is not gonna really work. Get. Consider the, okay, so I guess what it's saying is that I'm literally just going to give it a freaking number, and it's gonna know whether it's a Visa, it's gonna know whether it's invalid, if it's Amex, MasterCard, or, let's see, dude. It's either Amex, MasterCard, Visa, invalid. Nothing more, nothing less. Okay, so there's four outputs. For simplicity, you may assume that the user's input will be entirely numeric, devoid of hyphens, and not even print out the actual card, and that it won't be heavily leading zeros. But do not assume that the user's input will fit in an integer. Okay. I'm assuming that it would be just best for me to check the number that, like, so this is what's going on in my head right now. I say step one, do step, I'll just say steps because I don't even know how this is really gonna work. Steps, do lungs algorithm, and then look at first is it valid, as in num divided by 10 equals 0. If true, I'm going to have to look into first, see what type of card it is. Okay. But it's up to you to catch inputs that are not credit card numbers, a phone number, even if it's numeric. Alright then, guys. Seems like dude, I'm probably just gonna set it up tonight, but far as like getting this done, oh man, I just don't want to sleep in late no more. Okay. Visa. Shit. Visa. Cool. These are the test numbers. Okay. Eesh, okay, dude, this is gonna be tough. Alright. Well, how can I start this, I guess? I'm gonna need a pause right here. I'm actually getting pretty sleepy, guys. I'm gonna try to do this though. I just need a pause. But damn, I'm gonna get it. Watch, I'm actually gonna do this and I'm actually get it. So yeah, thank you guys for seeing the stream. Cash.c was pretty damn easy compared to this. Like it went from 0 to 100 real quick. So yeah, I'm gonna just pause this right here and I'm gonna get the answer. I'll keep you guys updated.